Hey everyone, welcome to Algebra 2 Live, Week 8, our lesson video on exponents and polynomials. So Week 8, make sure you're reading over the sections, watch this video. Hopefully you'll be learning enough and getting enough into all our Week 8 stuff to where you can start working on the paper pencils and all the other assignments for this week. Let me know if you have any questions. Come online, I'd love to work with you if you need some help or tutoring on any of these problems. Here we go. For the Week 8 objectives, I want you to be able to take, if I give you an expression, I want you to be able to use the product, the quotient, and the power properties of exponents to be able to simplify them out. If I give you an algebraic expression with negative exponents, I want you to learn how to simplify it correctly to make all the exponents positive. If I give you an algebraic expression, use all the different exponent properties that we review to simplify and rewrite these expressions in different forms. If I give you an algebraic expression, can you recognize if it is a polynomial and then use correct vocabulary in describing the polynomial? And then finally, if I give you two polynomials, can you add, subtract, and multiply them together? That's what we're going to be working on this week, a lot with exponents, a lot with polynomials. So far in this class, we're on week 8 right now. We're 2/3 of the way through Algebra 2A. We've been working with linear functions to solve problems. Forms in y equals mx plus b. We've worked with quadratic functions to solve problems. This whole y equals ax squared plus bx plus c. Now we're going to be moving for a couple 2-3 weeks here into working with polynomials. A polynomial is straight from your CK12 textbook. A polynomial is an expression with multiple variable terms such that the exponents are greater than or equal to 0. In fact, also, I would caveat with that, the exponents have to be whole numbers. You can't have fractions or decimal exponents. All quadratic and all linear equations, the ones we've been working with, are polynomials. So we're kind of getting bigger and bigger. We did linear, we did quadratic, now we're doing all polynomials. Equations with negative exponents, square roots or variables in the denominator are not polynomials. And so here's some examples for you guys. You can see here's a polynomial with 3 terms, 1, 2, 3. It's actually a quadratic expression. Here's a polynomial with x to the 3rd power. It's got 2 terms, so we would call that a binomial. Here's another polynomial, large one with 1, 2, 3, 4, 5 terms and has a leading coefficient of 4. And the degree would be 4 as well. So some vocabulary I want to throw out here when we're working with polynomials. We have coefficients. Coefficients, I think I spelled that wrong. Coefficients are the numbers in front of each term. They're the constants. So 8, or there's negative 8 would be a coefficient. 12 would be a coefficient. 4 would be a coefficient. They're the numbers in front of the variables. And then you also have terms. Again, we've already been working with terms, 3 terms, 2 terms, 5 terms. Every polynomial has what we call a degree. And the degree means the largest exponent. So linear equations, I'm spelling all sorts of stuff, exponent, there we go. I'm spelling all sorts of stuff wrong today. A linear equation or linear expression is a degree 1 because it has x to the 1st power. A quadratic, like this one, this is a degree 2 polynomial because it has x squared. This would be a degree 3 polynomial. And this large one right here with 5 terms would be a degree 4 polynomial. Here's some examples of things that are not polynomials. This first one is not a polynomial because we have a -1 exponent. Can't have that with a polynomial. The second one is not a polynomial because we have x, we have the square root of x. It's an expression, but it's not what we call a polynomial. And this last one is not because I'm dividing by x. I have x in the denominator. So there we go, quick review on polynomials. Again, in Algebra 1, typically you do a little bit with polynomials. So hopefully this is nothing brand new for you guys. As we start working with polynomials, we're going to be doing a lot of adding, subtracting, multiplying, dividing. We're going to be doing a lot of graphing and looking at polynomial functions. But before we do all that, it's a good idea just to review and get comfortable with all of our exponent properties. We're working with third powers now, fourth powers, and fifth powers, and possibly more. And so being able to know how to deal with exponents and do all algebra with exponents is important. So that's what we're going to do here for a little bit. Just quickly review over all the exponent properties that we've learned in the past. The key to understanding exponent properties is knowing that an exponent is just a notation for repeated multiplication, and that all exponents can be written in expanded form. So this 3 to the 5th power, if you remember, that 5 means I multiply 3 5 times. It's not 3 times 5, it's 3 times 3 times 3 times 3 times 3 5 times. This is really long to write and annoying, so we use an exponent to make it quicker and easier to understand what's going on. So as we go over all these properties, I'm going to put it in expanded form for you guys to help you see why each of the properties works. Okay, let's start with the product property. When you're multiplying, that's what product means, right? Whoops. When you're multiplying exponential expressions with the same base, that's key, with the same base, I'm going to underline that here. You can add the exponents together. So here we go. We got t to the 4th power times t to the 3rd power. Let's see what that means here. Well, that's 4 t's. 1, 2, 3, 4, all multiplied together, times 3 more t's. 1, 2, 3. And the result is we see that there are 7 t's all multiplied together. So that just equals t to the 7th power, right? But if we think about it, that was 4 t's, and I'm adding to that 3 more t's, so there's a total of 7 t's. We can rewrite and do this problem as t to the 4th times t to the 3rd equals t to the 4 plus 3. Which is just 7 t's. So the product property, I can just add the exponents together, but it only works as long as it's the same base. It's the same thing being multiplied. So in general, when you have the same base and you're multiplying them together, we can add the exponents. This is the product property right here. Now, just like there's one for multiplication, there's one for division. When you divide exponential expressions that have the same base, you subtract the exponents. Let's think about what we have here. We have x to the 8th, so that's 8 x's. 6, 7, 8. And I'm dividing that by 2 x's, x squared, right? Well, let's think about what happens now as we are doing our division. X divided by x, any number divided by any number, as long as dividing by itself, ends up equaling 1, right? So what I look for is division. This x divides out with that x to turn into 1. This x divides out with that x and turns into 1. But there's still a bunch of x's on top that don't have any more x's to be divided with. So it ends up just equaling x times x times x times x times x times x, 6 of them left over 1, which I can just rewrite as x to the 6th. So in the shortcut version, though, we see that if there's 8 x's on top, dividing by 2 x's, that means I'm going to have 2 x's that cancel out, and so it's just 8 minus the 2 that cancel, leaving x to the 6. We can subtract the exponents if we're doing division. That's the quotient property. And in general, again, you have to have the same number, the same base, but if they have different exponents and you're dividing them, you can just subtract the exponents to rewrite it and combine them into one variable. Okay, we have the power of a power property. For example, here we go. I got a to the 3rd, but then the whole thing is taken to the 5th power. What does that mean? Well, it means I have 5 sets of a to the third all multiplied together. So a to the third times another a to the third times another a to the third times another a to the third times one more a to the third. There we go. 1, 2, 3, 4, 5. That's 5 a to the thirds multiplied together. I can really go crazy and turn each of these into a times a times a, but I don't think we need to, because if I remember the product property, when I multiply with the same base, I add them together. So it's 3 plus 3 plus 3 plus 3 plus 3 should equal a to the 15th. There's 15 a's all being multiplied together. With the power of a power, I can think of it in terms of multiplication, right? That means I have a to the third, but there's 5 sets of them. That's a multiplication. So it ends up equaling a to the 3 times 5. There's 5 sets of 3a's all being multiplied. And so we can rewrite it like that. So the power of a power property, if I have a power being taken of a variable to another power, I can multiply the exponents together. There you go. There's in general. If you have some base and it's taken to 2 different powers, we can multiply the powers to simplify it out. So we got what? Product property, quotient property, power of a power property, different ways to handle and work with exponents. Let's deal with negative exponents. If a positive exponent tells you how many times to multiply, a negative makes things the opposite, right? So a negative exponent means how many times you're going to divide. Let's play around with a real example here. Here we have m to the third. That just means it's m times m times m, right? 3 m's multiplied together. But now here I have m to the negative third. What does that mean? Well, it means I take 1 and I divide by 3 m's. And so you can actually see that m to the negative third means you're dividing, not multiplying, by 3 m's. So when we're working with negatives, we often need to change our negative into either division or multiplication to turn our negative exponent into the positive exponent. We like to turn negative exponents into positive exponents. All right. We'll do some more examples combining all of these, but that's how negative exponents work. So in general, if you have a negative exponent, you can rewrite it as a division problem with a positive exponent. Or if it's already divided with a negative exponent, then the opposite of dividing is multiplying, so we move it back up to b to the positive m. Both of these are how we handle negative exponents and change them into the positive version of the exponent. All right, here we go. What do we got? We got the product property. If they're multiplied the same base, we can add the exponent. We have the quotient property. If we're dividing by the same base, we can subtract the exponent. Power of a power. If we have a power of some number plus another power, that's when we multiply exponents. And finally, with negative exponents, it means it's the opposite, right? We're not multiplying, we're dividing. Now we're going to put all these properties together. Let's simplify a couple expressions and see kind of how this works as we're dealing with exponents. All right, so I've got 2a to the third times 5ab squared all to the third power. We got a lot going on here. Multiple variables, numbers, exponents, and I want to simplify this thing down. Simplifying an expression means I want to make sure the fractions are reduced. I don't want repeating variables. So right now I have a here and an a there. I want to combine it into just one a. And I don't want to have any negative exponents. And we want to simplify things out. Here I got third power, second power, third power. Here we go. So it's helpful sometimes to write things out in expanded form. And so we got, I'm going to deal with this 2 times a to to the third times, but I got this whole mess of stuff right here, 5ab squared to the third power. The first thing I'm going to do is deal with this third power right here, because it's affecting all of this stuff in parentheses. So the third power is I'm going to apply the power of a power rule. Everything inside gets the third power. So I can rewrite this as 2 times a to the third times, there's 3 of them, right? So 5ab squared times another 5ab squared times another 5ab squared. This is one way to do it. If you get good at this, if you already remember all this, you don't have to write it fully out in expanded form, just helping make sense of what's going on here. And then with all of these, I can rewrite it out in expanded form as well. 2 times a to the third times 5 times a times b squared times another 5 times another a times a b squared times a 5 times an a times a b squared. All right, everything's all open. Multiplication is nice because it doesn't matter the order in which you multiply or divide. And why won't let me change? Can't change colors. That's annoying. So let's start to simplify things. I'm going to start with the numbers. So we got 2 times 5, which is 10, times another 5, which is 50, times another 5, which is 250. So with just the numbers, I've got 250 times, now let's go with my variables, a to the third times an a, so that's 4 a's, times another a, that's 5 a's, times another a, that's 6 a's, so that's a to the 6th power. And let's look at the b's. I got b squared times another b squared, that's b to the 4th, 2 plus 2, times another b squared, that's 6 b's all multiplied, so that's b to the 6th. So my final answer is that simplifies down to 250 times a to the 6th times b to the 6th. And we've just simplified that expression down. It's a little bit easier to work with. Only 1a, 1b, it's nicer. And we use, what do we use in this one? We used the power of a power property, and we used the product property. Let's do another example here. Here I've got one with fractions and negative numbers. So what do we got going on? Let's write it out in expanded form. So we've got 3 over 15 times x to the negative 2 over x to the negative 5th times y to the 3rd over y. This is one way you can approach fractions that helps you focus and deal with things individually. It makes it kind of nicer. 3/15, that reduces down to 1/5. That's pretty easy. The x's, how do I want to do it? There's a couple different ways. I use the quotient property, right? And do x to the negative 2 minus negative 5, subtract my exponents. Or I could reuse my negative exponent property and rewrite everything as positive exponents. So dividing by x to the negative 5th is the same as multiplying by x on top to the positive 5th. I can move that up. Likewise, multiplying by x to the negative 2 is the same as dividing by x to the positive 2. I can rewrite it now. Now I've just got positive exponents. I like that. And my y values are already positive exponents. So there we go. That's one way I can start to kind of navigate to this problem. Now let's simplify. Let's use my quotient property. X to the 5th divided by x to the squared is going to leave just 3 x's on top, x to the 3rd. And y to the 3rd divided by y, that's y1, leaves us y squared. So when it's all said and done, I have x cubed times y squared times 1/5, or all divided by 5, whatever is easiest to work it out. There we go. We just simplified that expression. We used the quotient property, and we used negative exponents to get it done. Hopefully that helps you kind of see some of these properties in action. Definitely practice these, look at some examples, watch some other examples, the video problems, or in your textbook, and that'll be helpful as well. Okay, we just went through the first 3 sections for this week, reviewing all of our exponent properties. Let's start to tackle some polynomials. So let's add and subtract and see what we got going on here. A quick review. We have a trinomial right here, 1, 2, 3 terms. So I'm going to mark that as a trinomial. And it is a degree 3 polynomial because the highest power is 3. Now I'm adding to that a polynomial with 4 terms, and it is a 4th degree polynomial because it's got a to the 4th. Now the thing to keep in mind when you're using adding or subtracting polynomials, we're just going to use the distributive property to help get it done and then combine like terms. So here I have 5a cubed minus 9a squared plus 15a, and I'm adding to that 3a to the 4th minus a to the 3rd plus 6a minus 10. Well, I can rewrite, because it's addition, I can rewrite it all without any parentheses. Pretty nice, huh? Everything is now opened up, and now let's combine like terms. So let's start with the largest exponent. I've got a to the 4th right here, but I don't have any other like terms, so I'm going to start off by 3a to the 4th. Now I'm going to look for the next largest one. There's a to the 3rd. So I got 5a to the 3rd minus 1a to the 3rd. I can put a 1 there. So all together, that makes 4a to the 3rd, and it's positive. Now let's look at squares. Here I got negative 9a squared, but no other things squared, so I still have minus 9a squared. I got 15a plus 6a, so that's going to be 21a. And my constant at the very end is minus 10. So the result is I have a 1, 2, 3, 4, 5-term polynomial. It's a degree 4 as well. There you go. That's adding a polynomial together. Subtracting is really similar, except I have to be just a little bit careful with the negative sign right here. This negative sign distributes, and I'm subtracting everything inside the parentheses. If you remember what that negative sign means, the opposite, we do the opposite. So let's see. We've still got 5a to the 3rd minus 9a squared plus 15a, but now here's where it gets different from addition. Instead of positive 3a to the 4th, it's minus 3a to the 4th. I'm subtracting that. I have a minus a to the 3rd, but I'm distributing the negative, so it turns into plus a to the 3rd. It's the opposite. Minus 6a, and then plus 10. So everything inside the second polynomial gets the opposite sign in front of it when you're subtracting. Now we can combine like terms again. Start with the largest one. That's negative 3a to the 4th this time. I've got a 5a to the 3rd plus a to the 3rd. So now they combine to make 6a to the 3rd. Negative 9a squared minus 6a squared. Those are going to combine to make negative 15a. Whoop. Whoa. 9a squared, I got to do like terms. That's not minus 15, that's minus 9a squared. Sorry about almost confusing you there. This is 6a to the 1st, so I can combine it with the 15. 15a minus 6a is going to give you plus 9a. And finally, we have a plus 10 at the end. So really similar when you're subtracting, except you just distribute the negative and take the opposite of everything. There we go. We just added and subtracted a polynomial. Not too bad, right? Stuff we already know. We already know the distributive property. We already know combining like terms. Finally, multiplying. We kind of already know this as well too, only we're just getting bigger and better with this. We multiply by using the distributive property as well. Each term gets multiplied with each term in the other polynomial. Sort of like what we did when we were factoring previously to check our work. But now I just got to get a little bit bigger. So this negative 2x to the 5th first multiplies 4x squared. So negative 2 times 4 is negative 8. And then x to the 5th times x squared gives me x to the 7th. I add my exponents. Now I do negative 2x to the 5th times negative 3x. Negative 2 times negative 3 is positive 6. And x to the 5th times 1x gives me x to the 6th. So for multiplying, again, we add the exponents on the same base. And finally, negative 2x to the 5th multiplies by the 10 to give me negative 20 x to the 5th. All right, now I got to move on to the next term though. Now I got to deal with negative 15x to the 4th times everything. So negative 15x to the 4th times 4x squared is going to give me minus 60x to the 8th. Whoop, x to the 6th. Look at that. I almost wanted to multiply them as well. X to the 4th times x squared is 6. So that's 6 x's altogether. Now I do negative 15 times x to the 4th times negative 3x. This is going to give me positive 45x to the 5th. And then finally negative 15x to the 4th times 10. It's going to give me negative 150 x to the 4th. Whew, all right. Now if you think about this for a second, we had 1, 2, 3, 4, 5, 6 terms altogether. 6 things we had to distribute and multiply, right? But that's because we took a binomial with 2 terms. We multiplied it by a trinomial with 3 terms, right? It can help you know how many things you should multiply by counting how many terms. 2 terms times 3 terms means we should end up with 6 terms altogether if we multiply everything. 3 times 2 is 6, right? Some of them may combine now, but at least that's a good way to get started. All right, so we multiplied everything, we distributed, we have our 6 terms because 2 terms times 3 terms is 6. Now let's see if we can combine any like terms. Start off with the largest one, x to the 7th. Nothing else has x to the 7th, so that's going to be my first term. Negative 8x to the 7th. Now let's look at x to the 6th. I got 6x to the 6th minus 60x to the 6th. So that's going to be minus 54x to the 6th. There, we've taken care of those terms. Now I've got negative 20x to the 5th plus 45x to the 5th. That's going to be 25x to the 5th. And for my last term, I've still got minus 150x to the 4th. So some things simplify nicely and you always want to double check. But there's what I get. When I multiply my 2 polynomials together, I get that degree 7 polynomial with 4 terms. All right, hopefully you followed along with all that. We kind of did a lot, but again, some good review. We used the product, quotient, and power properties, reviewed all that stuff to simplify expressions, reviewed a little bit with negative exponents and how to turn exponents into positive exponents. We combined them all, did a couple examples of simplifying expressions, used some polynomial terminology to find what a polynomial is and isn't, and we took 2 polynomials and we saw how to add, subtract, and multiply them together. So hopefully that's helpful for you. As you're starting in with this week's stuff, make sure you practice stuff, read through the textbook, work things out, take your time so that you're getting really solid in all your polynomial stuff for this week. Let me know if you have any questions.